Hi, we will now present a very important element of the CAPM model, beta. Most models in finance trying to derive the expected return that assets should be rewarded with given their associated risk depart from the distinction between firm-specific risk and systematic risk that we should by now be familiar with. As part of this starting point, they also assume that firm-specific risk should not be rewarded with a higher expected return because it can be eliminated via diversification, and that as a consequence, it is only systematic risk that should matter in order to determine the expected return that a financial asset should deliver in excess of the risk-free rate. In other words, the expected return rewarding ownership of a financial asset in excess of the risk-free rate should not depend on the entire standard deviation, but only on the fraction capturing fluctuations due to sources of risk that affect every firm in the economy. Models try to determine the proportion of this standard deviation that corresponds to systematic risk. As we will see, CAPM specifies this proportion by using the correlation of the return of the financial asset with the return of the market portfolio. Let us jump into it by presenting the formula that gives beta. Suppose that we're looking at a financial asset I with a given covariance with the return of the market portfolio. The beta of this financial asset is equal to such covariance divided by the variance of the return of the market portfolio. For the interpretation of this measure, it is important to rewrite beta in terms of the correlation rather than the covariance. Let us do this first. Recall that by definition, the correlation of the return of the asset and the market portfolio is equal to the covariance divided by the product of the standard deviation of their returns. We can factor out the covariance in this equality by moving the denominator in the right-hand side of this equality to the left-hand side to realize that the covariance is thus equal to the correlation times the product of the two standard deviations. We can use this to rewrite the expression of beta by substituting the covariance in its numerator by its expression in terms of the correlation that we have just derived. After the cancellation of terms that we can do there, we conclude that beta can be written as the standard deviation of the return of the asset divided by the standard deviation of the return of the market portfolio times the correlation of both returns. Now, we are ready to interpret beta. The first term measures total risk. Even though it is divided by the standard deviation of the market portfolio, such term only depends on the entire value of the standard deviation, in the sense that if we rank these ratios for all financial assets, the corresponding ranking will only depend on the total value of their standard deviations. That is, the ranking will be the same as the ranking obtained when comparing standard deviations, because this denominator, the variance, the standard deviation of the market portfolio, is the same for all of them. Now, the second term is the one that, as we anticipated earlier, establishes the proportion of this total risk that should count. That is, the proportion of the total risk that is due to systematic risk according to CAPM. Why is that? Well, recall that the correlation is a number between -1 and 1. So if we ignore its sign, it is indeed a number between 0 and 1. It is a proportion. If the value is 1, then all risk is systematic risk. If the value is, for example, 0.5, half of the standard deviation corresponds to systematic risk. If it is 0, All risk is firm-specific risk. Note that in this latter unusual case, none of the risk of the asset should be rewarded with a higher expected return. And thus, the expected return of the asset should just be equal to the risk-free rate. In any case, and to conclude, the beta financial asset gives, as anticipated, a measure of the amount of the total standard deviation of this return, which corresponds to systematic risk. In all this previous reasoning, we ignore the sign of the correlation. Let us now interpret the role of this sign. In CAPM, the return of the market portfolio can also be seen as capturing the state of the economy. That is, if this return is high, we find ourselves in good times. If such return is low, we find ourselves in bad times. Hence, if the return of the asset moves with the return of the market portfolio in opposite ways, that is, if the correlation is negative, the return of the asset is high in bad times. That is, at the time when we most need such high return. Hence, it provides insurance. Its fluctuations are then welcome. Know that we are willing to pay money for insurance. A natural conclusion is that not only should such risk receive no reward in terms of an expected return above the risk-free rate, such asset should have an expected return below the risk-free rate, that is, a negative risk premium. And this should be more so the more negative its beta is. On the other hand, if the return of the asset moves with the return of the market portfolio in the same way, that is, if the correlation is strictly positive, the return of the asset is low in bad times. That is, at the time when we most would appreciate a high return, we get a bad return. Hence, its fluctuations are not welcome at all. It is for this reason natural to conclude that such assets should have an expected return above the risk-free rate, that is, a positive risk premium. And this should be more so the higher the beta. This is all for now. See you soon.